Let's do some data analysis on our wooden cube data set. Here we've got a list of our blocks 1 through 27. They have a width, a depth, and a height. First thing we want to do is format our data a little nicer. So we're going to grab all the data with the mouse. Have a left click down, grab all that data, and then we want to use these buttons here to get to the point where we have three numbers after the decimal point, so we get down to the thousandths of an inch. And again, I use these numbers over here. This one decreases the number of decimal points, this one increases it, and so we want to be right at about 3. Also, we'd like to have these centered in the cell, so we can come over here to the horizontal align and we can click and then choose center, and then our data looks nicer and is formatted correctly. Let's click on the 1 here on row 1. We're going to right click, insert 1 above. So we're going to make some room here to put in the statistical quantities that we're after. So let's start right now. This is cell B1. So column B, row 1. So this is cell B1. We're going to do as follows: equals average, left parentheses. Then I'm going to grab my data in this column all the way to the bottom, and you can see that it says equals average, left colon, B3 colon B29. So colon separates two cells here, and it shows the data set consisting of all values between cell B3 to B29. And at this point we can hit enter, or we can hit the right parentheses to clean it up. I'm just going to hit enter. And let's see, you'll notice that we have the average value of that data set from cell B3 all the way down to B29. And it's 0.749. And if we click in that cell, we'll see that the formula creating that is right here. Okay, so let's do that for these two columns as well. And there's a great thing that spreadsheets allow us to do. We can come here to the lower right and just pull over into cells C1 and D1, and when we pull over, then the formula will update appropriately. So this cell represents C3 to C29, so it takes care of this column, and likewise for D. All right, so let's do another one. So let's actually give this a name, and we're going to go to the alignment tool and we'll right justify that. So, and then we'll come here and we'll center justify these. Okay, so we have our mean for each column here. Let's find the median. So that one's pretty easy as well. Equals median, left parentheses, go grab it with the mouse and hit enter, and you can see that it's also 749, so no difference there. That happens occasionally, but in this particular case, for the other columns, columns C and D, you can see they do differ just a bit. This is the median, and so again, I'm going to wait and right justify that later when I have the rest of my values here. And so what comes after mean median? I think it's mode. So this is going to be the mode. So equals, there's even a formula for that, equals mode, left parentheses, go grab the data, hit enter, and there's our mode. Now let's just drag it over to get it for the other columns, and let's go ahead and get it out to the 1,000th accuracy and center it like so. And we can right justify these. We can all do all this formatting at the very end, but I'm just kind of doing it as we go. Okay, now I think we've covered the quantities which measure the central tendency of a distribution of data. Let's look at the variance. So let's look at the range. Now, there isn't a formula for the range, You see nothing's popping up. So I have to use a different approach, a little less slick, but it works. So that's going to be the max minus the min. So we have a max 1, so equals max, left parentheses, grab the data. Now here's where we want to enter our right parentheses and then a minus sign, and that's going to be min, and I'm just going to write in B6 colon B32. It's the same data set, right parentheses equals, and we get our range right there. Okay, so I'm going to pull that over, and yeah, sorry, it just bothers me that they're not center justified, so I'm going to do it as we go. All right, I think we have one more. Insert above, and that's going to be the standard deviation. I'm going to abbreviate that as standard deviation like that. And then here, STDEV is the formula for that. Left parentheses, grab the data set, hit enter, and there it is. Okay, so that's a complicated formula, so that's going to give us a bunch of decimal places. Let's knock those down to 3 after 3 numbers after the decimal point. There it is. And we can just drag it over to take care of columns C and D, and let's center justify it like that. And just for looking nice, let's go ahead and right justify the labels. So there's our data. So we find that the mean of all this data is equal to 0.749, and again that data is the data from B7 through B33. Alright, so that's nice. Let's see if there's some other ways that we can better understand our data, and I want to show you something called conditional formatting. This is kind of cool. So let's come over here and grab all of our data here, okay, and then go format, conditional formatting. What this allows us to do is say, okay, based on the numerical value in a cell, color it differently. So we have to choose the criteria here. So I'm going to say if cell is less than 0.75, 0, which is the target of our size, or I'm going to format that as, I don't know, red, light red. Done. So using conditional formatting, you can see that we have quite a few data points that are less than 0.75. Okay, well, let's see which ones are above or greater than 0.75. So we're going to select all the data again, and over here, since we've already got some conditional formatting going on, we can just hit add a new rule, and that one's going to be if let's see, greater than 0.750. Let's make that green. Done. So you can see that we have slightly more data points that are less than 0.75, the target, and then are greater, and we have a handful, the ones that aren't colored, that are right on the money at 0.75. Okay, and for that matter, we can also use conditional formatting for our summary statistics. Why not? Format, conditional formatting. If it's greater than 0.75, then I think we called that, yeah, green. Done. Oh, just a few. And okay, that makes sense. And we'll grab the whole thing again, add another one if less than 0.75. Then we're going to make that red. Done. Most of our summary statistics come out just a wee bit below 0.75, so we can tell that just visually through the colors. All right, now what we want to do is we want to take the mean, median, mode, average, and standard deviation and apply it to all 81 data points as a whole entire data set. Now we could just combine these values, but we can't always do that. The only reason we can do it here is because we have the same number of data points making up these summary stats. So we're going to do it slightly differently. We're going to come over here just to the right here, and I'm going to come up here. I'm going to color this yellow. This is going to be different from this data. It's going to represent all 81 points. So let's do equals average, left parentheses, and now I'm just going to grab the whole thing as shown here, enter, and that is the mean for all of them, all 81 together, equals median, left parentheses, and I'm going to grab all these over here, enter, and then mode, I'm going to grab all of these. Let's see, are they much different than any of the individual ones? Not really, not too much. This data is pretty tight. I'm going to skip range for a minute and just do standard deviation, STDEV, left parentheses, and then just put the left mouse button down, grab all that, and hit enter. And let's clean that up. There we go. And let's do this one. The range is the max minus the min, so equals max, left parentheses, grab all of this stuff, right parentheses, minus min, left parentheses, grab all this stuff again, right parentheses, enter, and so we get 20. I guess that makes sense that the range is going to be bigger for all of 81 points rather than just taking them in groups of 27. All right, let's center these, and there we go. So we've learned how to generate summary statistics from our data. We've learned how to use conditional formatting to give us some information about the data set at a glance. Let's now take a look at some graphing. So what I want to do now is I want to come down here to cube statistics, and I want to come here and I want to duplicate this data set. So it's copy of cube statistics. Don't worry about these other tabs. I've used those before. Here what we want to do is we just want to come over here and we want to make a long line of all 81 points. We want to put those in a line, in a column, sorry. So Control C, I just typed Control C. I'm going to come up here to G2 and I'm going to say Control V. So I just copied all the width values here, and now I'm going to grab all the depth values here. Control C on the keyboard for copy, and then right below it Control V. So I'm making an 81 long column of the data. Control C, come to the bottom, and Control V. And for the column here, I'm going to have cube dimensions, and that'll be in inches. And then I can grab the G, come to the end here where it goes, gives you the two-way arrow, double click, and that'll automatically make that everything fit in there. And for now, I am going to get rid of all these other ones. I don't want that. So delete those. Okay, that's the data I'm looking for. So I'm going to then grab the data. I think I could just click the A at the top and it would have grabbed the data. But I did it that way, and we're going to go Insert, Chart. And Google is going to give us what it thinks might be a good chart for us. This is, let's see, chart style is what? Let's see, data. It's a line chart. Okay, so this is kind of how our data evolves over some arbitrary index down here from 1 to 81. There's 0.75 right here, and you can see it's jumping around. What might be more useful to us is to change the line type to the histogram. Now the histogram is not going to be perfect because our data is so tight. But what this shows is it has all the values down here that we've measured on the bottom on the x-axis, and then on the vertical axis it's got the number of points that fall within the ranges here. So between 0.74 and 0.76 we can just hover there, 70 of the 81 points. And then less than 0.74 we have only 4, and greater than 0.76 we have 7. So this is pretty tightly controlled data, and we can see that immediately with the histogram. Now we can come over here, and we don't really want this legend here, so we can customize, go over to the legend and just say none, and now we get a little bigger data point. In general, you want your labels to be, let's see, font size should be bigger. Bigger is better in general on a graph. You don't want to have to squint on a graph, so I'm going to make those 20. Here I am going to, again, let's see, bold it, and for font size I'm going to choose maybe not quite that, well yeah, I'll take 20 again. Remember, bigger is better. And can we change the size here? I think we can. We want that to be nice and big. Cube dimensions 20. Why not bold it? And how about our title up here? Let's make that even bigger. Let's make that 24. And of course bold it. And there's our graph. And this shows very succinctly the distribution of our cube values. Thanks for watching.